going to add 10. Those 2 goes away. Oh, sorry, it doesn't go away. That becomes 0. A lot of zeros here. Half x minus 4. So to get rid of that half, right, we're going to multiply that by 2. Multiply that by 2. That goes away. I'm left with x minus 4 and greater or equal to 0. When is that true? So again, so pull that to the side just for a second and think of all the numbers that I can put in here to make that true. What values can I put in here? Can I put 0? Yeah. Can I put 1, 2? Actually, this could be all real numbers because it doesn't, let's see, sorry, I forgot the absolute value of. I think this could be all real numbers. So let me just think about it. If I put 0 here, would that make that inequality true? Yeah, because 0 works. What about 0.1? Yeah. So every number in here works, right? I could take the absolute value of every single number that way. And what about numbers this way? Will they work? -1, take the absolute value, it's 1, which is greater than 0. 0.1, negative 0.1, that works. So in this case, it doesn't matter what it is, it will always be greater or equal to 0. So this would be all real numbers because it doesn't matter what I replace x with. You can think about any number, you will always get a number that's either equal to 0 or greater than 0. Okay? 21 half x plus 2 plus 6 less than 15. So we're going to do minus 6 first on both sides. 15 minus 6 is 9. So that goes away. Half x plus 2. Divide that by 3. That simplifies to 1, and we're finally left with this. So less than 3. So think about this. When is the absolute value of anything less than 3? Well, let's put 3 over here. Well, we know 3.145, that doesn't work, but less than 3 works, right? The absolute value of 2, the absolute value of 1, 0, -1, -2, and so forth. But it stops here. Because at 3, if you put -3 here, it won't work. So this is an AND problem. Finally, we have an AND problem. So the values of x, right, numbers that I can replace the x with, they have to be between -3 and 3. And that's how I'm going to set up my inequality. Less than 3 or greater than 3. -2 on both sides. This is going to be, sorry, this is -3. So 3 minus 2 is 1. I get half x. I got rid of the 2's. This is -5. Now I'm going to multiply both sides by 2. Everybody by 2, right? Because doing that, if I multiply everybody by 2, this goes away, and I'm left with x, which is what I want, my variable isolated. 1 times 2 is 2, and 2 times -10 is -5 is -10. So the solution on a number line looks like this. 2, -10. So x can be any number between -2 and 2, not inclusive, right? So let's just pick -10, not -10. Let me pick -8. So if you put -8 in here, -8 times a half is -4. -4 plus 2 is -2. Take the absolute value. -2 is 2. Is 2 less than 3? It works. Let's try 1, which is over here, right? Let's try 1. Half times 1 is 1. Sorry, half times 1 is 0.5. 0.5 plus 2 is 2.5. Absolute value of 2.5 is 2.5, which is less than 3. So x, values of x, right, can be anywhere from -2, -10 to 2. And then we have 4 more problems on the back page. I have no idea what they are. Let's see. I have a picture. I think I took a picture. We're doing 16, 19, 20, 22. 16, 19, 20, 22. So let's do 16. 1 minus 4k greater or equal to negative 11. Okay, so you guys, ooh. All right, let's think about this. When is the absolute value of anything, before I set up my problem here, start solving it, when is the absolute value of anything greater than negative 11? Always. It will always, take the absolute value of anything, it will always be greater than negative numbers. So the solution, we don't even have to solve this, is all real numbers. Any number, right? So if you replace k with any number, so 1 minus 4 times any number, it doesn't matter what it is, whatever we get here, it will always be greater or equal to negative number. Sneaky, who picked this one? Nice problem. 19, nice, because, so r minus 2 minus 10 less or equal to negative 73. So plus 10, negative 63, that goes away, 9, r minus 2, oh, gee. Divide both sides by 9, those two simplify to 1, we're finally left with r minus 2 less than negative 7. Okay, so think about this. Somebody give me a number that you can take the absolute value of, and it's going to be less than negative 7. It's not going to happen. The absolute value of every single number will always be greater than negative 7. So there's no value here. There's nothing I can put in here. Nothing. You can plug in r. You can plug in a value for r, any number, and it will never ever. You take the absolute value after you subtract 2. It will never be less than negative 7. So this one, there's no solution. It's just not going to happen. What's next? 20 and 22. Oh, good. All right, so 27 minus 9 less than 12. So let's do plus 9 to both sides. That goes away. I'm left with 7 and over 3 absolute value. That's 21. Divide both sides by 7. And I get this, less than 3. So now we finally have one we can work with. So again, ignore the n over 3 for a second and just focus on this. When is the absolute value of anything less than 3? Well, not 3, but numbers less than 3 works, and all the way to, but not including negative 3. So any number between negative 3 and here, you plug in there, it's going to be less than 3. So now what we got to figure out is, what number can I divide by 3 so that it gives me a number in here, right, between those. So n over 3 has to be between 3 and negative 3. We're going to clear the fraction, so let's multiply this guy by 3, multiply this guy by 3, multiply this guy by 3. So we get negative 9 less than, that goes away, left with n, and there we go. So our solution on the number line looks like this. So n, the values of n that will make this inequality true, not including 9, right? So I don't know, let's pick 6 because it's nice divisible. So 6 divided by 3 is 2, and 2 is less than 3. Good. Pick negative 6. Negative 6 divided by 3 is negative 2, and absolute value of negative 2 is 2. Is that less than 3? Yes. So every single number between negative 9 and 9, not including those two values, plug it in for n, and we'll make that inequality true. So this looks like this. Okay. $22, I think. 7 plus 6v plus 7 less or equal to 60 minus 7 minus 7 goes away. 6v plus 7 less or equal to, what is that, 53. Okay, so this one's a big one. Again, take that to the side for a second and think to yourself, what numbers can I plug in here that make that inequality true? So 53 works, right? Because the absolute value of 53 is 53. 54 doesn't work, so we don't want numbers that way. So 53, 52, all these numbers work, and you can tell that we're going to go all the way to and including negative 53. All the numbers between negative 53 and 53 included. If you plug it in here, it works. Now, your job is to figure out what can I multiply 6 times what number plus 7 will give me a number between negative 53 and 3. And that's what we're looking for, right? V. What can V be? Can V be 10, 11, negative 8, negative 9? What can V be? And that's what we're looking for. So now that we establish what it can be, so this right here, 6V plus 7, and if you like, you can write and problem, has to be between 53 and negative 53. All right, so let's do minus 7 first on both sides. That goes away. 53 minus 7 is 46 positive. This is negative 60. I'm left with 6V. We're going to divide everything by 6. Right? I finally have my variable by itself. So V, this is negative 10, and this is, I'm going to change it to a, what do you call, a mixed number. So 6 goes into 46 7 times, which is 42, and 4 sixes, or 2/3. So if you draw a number line, V can be a lot of numbers. It can be negative 10 all the way to 7 2/3. So these are values of V. And then if you want to be fancy, this one we're going to use brackets, 7 2/3. So again, just out of curiosity, pick negative 10, see if it works. So if we put negative 10 over here, we get 6 times negative 10, which is negative 60. So let me write that, negative 60 plus 7. That's going to be negative 53. Take the absolute value, negative 53 is 53. So that works because 53 is less or equal to 53, right? So, and if you want to, let's pick negative 11 just to see that it doesn't work. So let me pick negative 11 and plug it in there. So if I plug in negative 11, I get 6 times negative 11 plus 7, less or equal to 53. This is negative 66 plus 7. That's going to give me negative 59. Sorry, did I do something wrong? Yeah, hang on a second. 6 times negative 11 is negative 66. Negative 66 plus 7. Negative 59. Take the after that. 59 less or equal to, sorry, this will be 53. Is 59 less or equal to 53? No, it's not. So you can tell that already numbers on the left side, to the left of negative 10 doesn't work. And that proves, right, that our solution has to be a number. So V, right, the value of V here has to be a number between negative 10 and 7 2/3. Okay? Hoping that helps. Okay?